started?
Yeah, I think so.
All right, so thank you again, everyone, for joining in. My name is Dai. I am the Principal Robotics UX Designer here at Brain Corporation.
And my name is Hamid. I'm a developer on the autonomous navigation team. Thrilled to be here with my colleague Guy, and we're going to be talking about humans, robots, roles, and jobs.
And the importance of UX in driving that conversation on how robotics gets integrated into an industry and what that perception is like and what basically is needed in order for that adoption to take place. And today, when we go through, we're going to talk a lot about our own personal experiences, both from engineering and from the design perspective. We're going to be talking about everything from our customers to our partners, and also kind of lessons learned along the way. And a part of that conversation will be about how we researched and went through the building process of not necessarily looking at automation replacing only tasks, but building a product in which created a symbiotic relationship between human and robot. And then also leveraging things that we already knew about the industry, or things that existed before we were developing our product, that helped in the design process, helped people learn how to use the robot. And also considerations on when you introduce a brand new technology like this, what it means to understand how it impacts people, how it impacts their job, and impacts their day-to-day life, because we know that our job, even though it's at work, it comes home with us personally.
Yeah, it does. Definitely, such a big part of our identity is what we do. How we perceive ourselves is really tied to our profession.
Okay, so let's dive into that one hard-hitting question that we always get to. I know whenever we're out testing, when we're talking to customers, or whenever someone asks us, what do you do? And we say, oh yeah, I work in robotics.
Yeah, I was actually at jury duty a couple of weeks ago, and the first thing that they ask is your occupation, going back to how much that's tied to our identity. And I told them I was a robotic software engineer, and the judge immediately asked, so in 5 years, are robots going to replace us? And I think that is really the big elephant in the room when we talk about robots and the future of robotics and AI is, are robots going to replace us humans?
And something I want to be clear and cognizant about is that when I understand that we come from a position of expected positivity, just as you mentioned about jury duty, I was inside of an Uber and they usually ask, what do you do? And I said, oh, I work in robotics. And what type of robotics? And I say, specifically for autonomous navigation. And he goes, not gonna need me in a few years. I said, well, let me tell you. But that's kind of the conversation that I wanted to, that's the reason I wanted to talk to you, because we have these conversations over coffee or over lunch all the time, and we share these anecdotal things, but I don't think we get the opportunity to sit down, talk with a group of viewers, and kind of expand beyond just the engineering nuclear family.
Yeah.
And see, what are the other topics that people are thinking about. So first, let's go through technical feasibility.
Biggest hurdle, in my opinion, from a technical standpoint, we have quite a few very large hurdles to tackle before we can have robots come even close to replacing a human being. Chief among them being power density and battery technology, even down to the state of charge estimation of a battery. We're just not there yet. Humans are extremely efficient animals when it comes to the amount of computation power that we have in our brains and the amount of power that we consume. I mean, if you think about your laptop, if you have it running at full blast, the CPU at 100%, all cores running, you might last, even the best batteries, maybe 3 hours, maybe 4 hours, which is just not where humans are. A human being can last much longer than that, and they are capable of far more computation than a laptop. So yeah, battery technology in and of itself is going to be a very big hurdle for us, and I don't think we've come a long way since a few years ago. Now the exception would be Tesla, that's been pushing the boundaries, but I think even there we're starting to hit some walls.
After lithium ion, we kind of plateaued a bit on the innovation when it came to our capabilities, when it came to power source. It's also the demand that we have out of our technology too. Do you remember the Brew J2ME days with like the Razors and Nokias?
Yeah.
And I don't ever remember having to carry around an external battery, even needing to charge my phone in the car.
Yeah.
But now I can't make it through a day without, watching a few YouTube Live podcasts or going through Instagram or taking photos, or even when we're doing documentation in our lab and everything that we do day to day, the battery capability isn't at the par of what we expect from our technology.
Yeah, those were simpler times, weren't they? Yeah.
Something that someone brought up to me, they go, well, what about when the robots learn how to charge themselves and everything? And I think that's when I kind of jump into this idea of the lack of credit that we give ourselves as a species. I think when we talk about technical feasibility, people and how complex we are as a species, and if I were to reach out and high five our YouTube Live folks, or if I'm going to toast you for joining me on this webinar, our day-to-day lives and our day-to-day decisions are driven by our limbic system that are sometimes in conflict with our cortex, and then so many neurons are firing, and there's tons of biological, mental, everything processes and things that are just firing at that right moment so that we can communicate effectively.
It really is impressive when you think about it, and we just take it for granted. Just trying to create a robotic arm that could mimic even half of what a human being can do and pick up a simple object requires a tremendous amount of engineering. So from that aspect, I agree. There is a lot to be said for computational power of our brains, of our cerebellums, not just the cortex, but also the fact that we take it for granted so much, and we really need to integrate so many aspects of system design in order to be able to even come close to operating the same way that a human being would.
And I think that's where we kind of start looking at, okay, technical feasibility, but also human resilience. In the sense, if I turned off all the lights and you weren't able to see through this room, you'd be able to find your way out and navigate out and be able to figure different coping mechanisms. If I ripped out your arm, which I promise I would never do, you're my friend. But if I took a limb away from you, that there's an innate adapting behavior and mechanisms that are built into us that really allow us to persevere through tough situations.
Indeed, I think that if you did anything of the sort, even close to that with any robot, the robot would simply cease to function. If any device that we really create, any vehicle, I'm expanding it into robotics, but even simpler things, automotive, you take out a tire, the car's not going to run. Aircraft, they're one of the most redundant systems. It still requires routine maintenance. A pulley goes out, you need to do upgrades on it or replacement parts before the thing is able to fly again. And so that's another aspect of human beings and really animals where we demonstrate a tremendous amount of resilience and as you said, coping mechanisms for damage, for sustaining damage in the field.
Humans are specifically resilient to adversity, and that we'll touch on that adaptive nature for the changing landscape of technology in a bit. But before we jump into that, I wanted to talk a little bit about adoption and trust. I think the reason why we chose to tackle this topic first, of robots taking jobs and replacing humans, was because it's a warranted fear. I don't want to say fear, but it's a warranted conversation to be had because the discussion of our human value and our place in society and how we provide for our families and our livelihood ties into kind of that adoption and trust, meaning we need to create something when it comes to robotics and it comes to new technological advancements in general. You have to create something of value in order for it to be adopted.
Yeah.
That adoption has to come with at least a perceived level of trust and understanding. And without adoption, there is no success.
Yeah, I think that, I like to view robotics as just the next step in a long series of evolution of technology that's been happening for hundreds of years. And that is just a better, faster tool. Robots by themselves are not able to think and make decisions. And even if we had a very complex robot that was self-aware, it would lack a limbic system, it would lack purpose, it would lack motivation. And having said that, then it really comes down to who is going to be on the other end of the robot wielding it and working with it. And so adoption of robotics, I think, shouldn't be any different than adoption of any new technology that we've had in the past, whether they were cars or whether they're iPhones. They will need to interact with people, and people will need to trust that they're going to operate them and be able to understand how the system is going to behave.
And we'll touch on this part a little bit when we jump into the design part, but there's a part of the adoption and trust that it ties back to that principle of technology that is built by our hands should be done to serve us, serve a purpose, serve a value that benefits either a economic problem, a sociological problem, an employment problem, some sort of problem. It has to provide a solution. Up until this point, robotics isn't a new topic. It isn't a new, there's always advancements in it, but it on some degree has always existed. So with that, when we look back at older robotics products and we look at older technology that existed similar to what we're trying to do but did it differently, it didn't get that widespread adoption because it didn't solve a problem.
Yeah.
And there wasn't an inherent value in why someone either in their job or in their home should take it. When we look at, say, something like the Roomba, there have been robots prior that were based on collision-based trajectory or collision-based navigation.
Yeah.
But until someone said, hey, fine, if you're gonna bounce around, why don't you vacuum someone's house?
At the same time, yeah.
Yeah.
What a great idea. And I think, the adoption of the Roomba has been one of the greatest examples of robotics in the home. And also, to serve a point, that you still do need a human being to clean your house. The Roomba has not taken over.
No.
It helps, it's a great tool, but by no means is it perfect at vacuuming your floor. If you just let a Roomba run around, you're not gonna have clean floors. You cleaner floors, yeah, but not the clean floors that a human being would be able to do in a meticulous and deliberate fashion. So, they did a great job, I think.
And then thinking about automation, you and I are huge car enthusiasts, so we touch on the automotive industry a lot. And this it ties into public perception and also the adoption aspect, which is when the assembly line came in. A lot of the building of a car, the human aspect got taken out. But then all of these industries emerged from that. Now cars can be produced at a higher rate to keep up with population demands. And in addition to that, now there were new engineering jobs, there's new facilities jobs, there's new aspects that prior to that didn't exist.
Right, and it was very difficult to predict at the time what was going to happen and that these new industries were going to be spawned as a result of this new technology. Well, I don't think that's like what I was saying.
For those tuning in, we just had one of the picture frames drop. These are the great things about being live. You never know what to expect.
Yeah.
Here,
All right. Let's put that robot over here.
And like humans, what do? We adapt.
That's
We're
right.
resilient, and then we find a nice solution. So, for those not tuned into the YouTube live, we put the robot frame right side up, and it's positioned towards the back now.
You can still see it.
Yeah, you can still see it. it's a nice backdrop behind the slide bags that we're giving away.
So, as I was saying, the industries that spawn, the industries that the robotic industry that services the automotive manufacturing industry spawn, were not things that people at the time could predict. The engineering jobs that came out of it, just the complexity, the added complexity, was not something that people even thought about. All they thought about was the legitimate fear, in my opinion, of how is this robot going to take my place?
And I think that's where it is so important to shape this conversation, is that automation, robotics, and AI are not replacing people. You know, let's use very specific words here. It's not a matter of replacing people, but it's a transition of tasks. It's a transition of the job market. It's a transition of how we live in our day-to-day. And change is hard. Change is concerning because the unknown is always concerning. But looking internally, so when we first started our company, I was part of the early team jumping on, we had no idea, at least myself, we had an idea that things would transform. We had an idea that by introducing just this thing as an autonomous floor scrubber is going to impact the janitorial industry. We're trying to solve a problem of freeing up time for the janitor. We're trying to kind of take away the monotonous things that would now free up time for someone to do something of higher value or do something that they potentially didn't have time to do. We'll discuss more into that later, but internally, the user experience now didn't just become external facing. It wasn't just the businesses, it wasn't just the customers. I look at the amount of roles that have boomed and employment opportunities and really learning opportunities and the landscape internally of our own company that have grown, and it's really incredible. For example, initially we had a team that would deploy robots, and they were part of the field analysts that would analyze the environment, kind of facilitate this transition and help our customers with their workflow and help the customers with understanding how to integrate this robot. And then from there now, a whole system of tools are being developed. So I'm working on user experience for analytical tools, tools for technicians that were previously assembling manual machines, now assembling manual machines that have a robotic component and a navigation component. We have an internal team that grew just to support the customer side, the customers that want to communicate back with us, and it keeps growing.
Yeah, I think that's a theme that's very recurrent with technology, is that as new technology comes about, we really have to think about all of the aspects of this new technology that then need to be serviced, and something higher than that technology needs to be able to manage it, and needs to be able to service it, and needs to be able to grow it. And that is, in my opinion, a very natural evolution, and it doesn't happen overnight. It is gradual, and I think that allows time for people to adapt and to focus on things that are, as you said, of higher value.
Something we saw in this past year happening, and the team that I work with that go out and do observations and get customer feedback from using the floor scrubber and really understanding our product, it was something that we had intended for and planned for and designed for, but at the magnitude it was of course unexpected, in the sense that because the janitor uses our machine every single day, they became our first line of technical support. So now, from a cleaning professional, they transition to this robot operator, robot technician, and in a sense, they knew that machine best. And in working in some of the interviews that we conducted, the janitor would now then transfer that knowledge and teach others how to use that machine, what the data meant, what some of the analytical parts of the UI that show about the cleaning mechanisms work. And I'm thinking about that ripple effect going outside of the workplace, and I'm thinking about if we have a workforce that can be transformed with newer tools, different things to learn, and be able to spread that knowledge outward. It's this kind of cool thing I'm thinking about where we now have a more empowered workforce
Right.
with a new tool set and just an elevated workforce.
Yeah, and it all starts with the adoption, as you said, of the janitors. If the user experience of the janitor wasn't there to facilitate that, I don't think that the product would have been nearly as successful. And so that's why I think that the idea of providing a solution that is not intimidating
Mm-hmm.
for someone to learn is really where the key to success lies.
Yeah.
Especially in this example that you were bringing up, I think that's a great example of that.
And I think when we talk about the fear of robots taking over or what's going to happen technologically, and we look at how technology gets introduced, it's not overnight. It's not this huge thing that kind of transitions and gets dropped onto you, and you now have to figure out what to do with your job with the current technology you have. It has to be an incremental evolution. Bringing it back to cars, when the best example I can think about this is when cars first started coming out, there's this task of long distance driving and maintaining a speed. And that fatigue that happens in your ankle from adjusting the gas pedal.
Yeah.
For adjusting for speeds and then, keeping your foot there.
Mm-hmm.
So then cruise control came in. And now when we think about it, cruise control is kind of part of our cars, it's a part of everyday thing. We never even really think about that introduction of cruise control.
Yeah, it used to not even be standard, right? It used
No.
to be an advertised feature of the
Yeah.
car. Oh, it comes with cruise control, and now everyone takes it for granted.
Yeah, and then from cruise control, now we jump into the Tesla and a bit of autopilot, which
Mhm.
still requires and promotes human intervention and human awareness, but it takes a little bit of the fatigue and load off of driving.
Yeah, it does. I use it every day on my drive, especially in stop and go traffic, and I think it's wonderful. But as you said, it is just a small step. We had just manual cruise control where the accelerator would hold a position, would hold a speed. Then we had adaptive cruise control where we put sonars in front of the cars and they could detect when the car in front of you was slowing down, and all you had to do was steer. And then the next evolution was the lane keeping, where we put a camera on the car and we could see where the lane was and we would turn with the road. And in each one of those cases, it wasn't an entire solution that was dropped onto the consumer. I think if the Tesla Autopilot, for example, was introduced as a completely brand new feature without the predecessors of cruise control and adaptive cruise, I would think that people would be apprehensive in trusting such a thing.
I think you can see that in the industry now. There's a lot of companies that are doing the self-driving vehicle, and when you introduce things in an incremental method, you can gain feedback, and that's the thing that UX designers thrive for and software drives for, is that kind of iterative process where you can get that feedback. And I think the way Tesla's doing it is very beneficial in that sense where, we've seen what's been problematic over the past year. We've seen the technical limitations, and in that too, we can see the upgrades and how things get better.
Yeah, it's very interesting that this is a thing in UX, because it's a very well-studied component of software engineering, where before we used to have waterfall models and you would have to have a requirements document, and you would send that off and someone would build you something and drop it in your lap. And now we encourage agile programming, we encourage incremental and continuous integration of systems, and I think that the benefits of that are really to make small course corrections as time goes on.
Yeah. Let's talk about the design of designing the successful product, but from both of our perspectives. I know this is where I'm gonna start discussing heavily on our first product, which was the floor scrubber. And tying back to when we first started this talk, designing a successful product, what does success mean? Success usually means adoption,
Right.
functionality, solving a problem. And with the floor scrubber, when we first started doing research, I remember coming in and we had this cart with sensors on it. And it's like, well, what do we do? And the first vertical that we jumped into, the janitorial industry, it's one of those industries that lie very low.
Mm-hmm.
Most people don't, you know that it's a necessity. It impacts every single business, it impacts every single facility, and every part of our day-to-day lives, from
Yeah.
how trash is handled from exiting our home to every aspect. So it was this kind of untapped industry to jump into and say, okay, let's look at where we innovate. And with the floor scrubber, the early conversations, there was apprehension where people would say, are you replacing our role?
Mm-hmm.
And very early on, we decided, okay, we are not building a brand new robot. The thing that we see in TV, the things that we see that are bright and
Right.
shiny,
Lasers, you know?
lasers, lights everywhere,
Yeah.
shiny modern plastic,
Yeah.
and like carbon fiber, all the things.
Yeah.
I throw that as a joke because I wanted a carbon fiber steering wheel on
That
our
would be
first
pretty cool, yeah.
I know, on our first scrubber, but one of the things that made it very welcomed when we introduced the floor scrubber was that it looked like a floor scrubber. There was nothing flashy about it. There's a lot to the industrial design that makes it look cool, but if you look at the rotomold material, it's very industrial. It looks durable.
Yeah.
If you used a floor scrubber before and you saw our floor scrubber,
You'd recognize it.
and that was the point of introduction, was it's a manual machine that is also autonomous. We're automating manual machines. We're not trying to reinvent what a robot is. We are taking something that exists and automating it.
Making it better, just the next step in the evolution. I think that is I've never seen a floor scrubber before, honestly. I mean, I know I've seen it, but I didn't really pay attention, and I didn't really see it. And it's actually quite surprising to me how large this industry is. And I think that this particular aspect of the design was something that this company really got right, which is to have a product that's familiar to someone so that they're not intimidated by it, so that they are not apprehensive about learning it. It's still a floor scrubber, you can still use it the same way that you did before. And this sort of greases the rails, in order, so to speak, in order to adopt a new and better and autonomous robot. Really, it's a complex piece of machinery, and yet you can recognize it as a floor scrubber.
And taking it outside of the floor scrubber for a second, when we introduce new technology as a society, there's this marketing aspect of it where everything has to be reinvented.
Mm-hmm.
It's shiny, it's new, and I think there's merit to looking back and looking at legacy design items and form factors that have worked. So when it came to the scrubber, I remember we were working on one aspect, which was the manual functions.
Mm-hmm.
So part of the design idea was we will keep manual functions separate and we'll keep autonomous functions separate. In the sense where if I jumped on this machine, I could use it manually.
Yeah.
I don't have to go through a bunch of buttons and UI items and complicated tasks to kind of enable the autonomous mode.
Yeah.
You, at any point, it is a manual machine, and then on one side, once you wanted to put it into autonomy, you could with a couple button clicks. But in the manual machine aspect, I go, okay, well, now that it's an autonomous machine, we should revisit maybe the iconography and design language. So I'm looking at this vacuum, and a couple of the designers and myself, we start concepting out iconography. And we started doing user testing, and I looked at the icon, I go, this is a vacuum, this is definitely a vacuum. In my head, I never say that out loud,
Yeah.
because you wanna go in
Unbiased.
not unbiased.
Yeah.
And I remember the janitor looked at me and she said, well, so that looks like a hand vacuum, like the ending of a hand
Right.
vacuum, but it doesn't, your machine doesn't have a hand vacuum.
Right.
I said, very good point, thanks. And then I realized that there were a few things we could tweak, but there were a lot of items that existed from the machines that came before us
Yeah.
that had so much legacy behind it that it required minor design changes.
Yeah, the
to
knowledge, leveraging that knowledge base, I think, is so key. I agree, yeah. It's, designing something new, it's tempting, right?
Mhm.
Because you wanna do something cool, and you wanna show off a little bit. But, resisting the urge, making something simple, and something that is almost self-explanatory, so that when someone for the first time sits on it and tries to use it, they don't have this apprehension about, well, I can't learn this because it's obviously very complicated and I need to go take a class to use this machine. I think that is such a key aspect that led to the successful adoption of any robotics product, really.
And I think one of my favorite parts through that process was adopting our autonomy portion to that legacy design language.
Mhm.
So now we had this hybrid of, okay, how do I translate gyro, LiDAR,
Right.
sensor error messaging in the sense of this legacy design language that exists on a machine. And that was, you're right, simple is never easy.
Yeah.
Simple is never easy, and there was a lot, and you know this, there's a lot of heavy lifting that goes on in the background just to support that manual function.
Yeah, well, I mean, from the technical aspect of it, a big portion of our code base is the manual operation of the machine, because we're essentially, putting a component in between what used to be the analog motors and the gas pedal and the brake pedal, and we are digitizing that. And tremendous amount of effort went into it, especially on our firmware team, but also on the high level and the UI aspects of it, to be able to continue to support that manual function. And I think that is a deliberate decision that we made in the course, in the pursuit of having a machine that's recognizable right off the bat, and you know how to use it right off the bat.
It also reduced the apprehensive nature of the apprehension of getting on the machine and just starting to use it.
Right.
We kept the form factor of having a key, rather than going with, say, a push button or something, because it was something tactile that gave the user feeling that it was ownership of this tool now, which is same with the steering wheel. You steer the machine the same way you would a vehicle. Psychologically, when you walk up to the vehicle, there's a place for the human still. There's a seat on the machine.
Yeah.
So, and the seat is elevated above the machine. So, at any point, even with autonomy, there was a dual perception that this garnered, in the sense that from the customer perspective, if I see this machine driving around by itself, there's audible cues, LED cues, visual cues, we'll jump into that next, but I see a seat there, it goes, okay, so I guess a human should be there, but it's driving autonomously, but a human must be related to this thing somehow. And then from the janitor side, it was no matter what, there are hardware buttons and there are things that put me in control of this machine, and at the core, I'm the one in charge.
Yeah.
And I'm the one dictating the tasks.
A customer not being afraid of a robot, I think that was, and seeing it for what it really was, definitely a good design choice, in my opinion.
And this ties into now the design of the machine and the user experience that is beyond just the display. There's this common misconception that when you talk about the UI, that UI is this tiny interface that's a display, and it's so beyond that. The UI is basically anything that would interface outward with a human and a human interfacing with the machine. Using one example, so our robot in the rear is a blue button. This blue button to this day is still a topic of discussion, research, and usability and conversation all the time. But when you build a machine, safety is one of the supreme things that can never be compromised.
Yeah, especially this 800-pound beast, right? I mean, yeah.
So the blue button is how you initiate for the robot to go into autonomy, go clean an area, and it's also how you pause the machine. We position the blue button in the rear so that, in a sense, it was forcing the user to get off of the machine, they had now a secondary, not forced, but kind of supported behavior where they have to peripherally scan the environment
Yeah,
because they had to
because
get
they
off
had
the
to get off,
machine
yeah,
and push the blue button. And then as they're behind the machine, it was one last scan forward saying, okay, everything's clear. They push the blue button and the machine moves away from the human.
yeah. I mean,
But-
just that action, right? It's like a parent, encouraging a child to go forward, yeah.
That gentle hand
That's
gesture
right.
of like,
Go ahead, it's good.
Be
Go play.
free. Do the things you were meant to do.
That's right, that's right. All the time, knowing that they are still in control.
Yeah, so for example, many times when I was doing observations, the janitor, the technician, whoever it was,
Mhm.
operating the machine, if they forgot something on the seat, if they forgot to secure the yellow strap, if they forgot to anything, it allowed that secondary undo moment where I could then pause it and then address the things I needed to address
Yeah,
and then reinitiate that process again too. And that in itself was a huge interaction design process.
yeah.
How long does the machine pause for? Eugene actually brought up one of the early on feedback items that drove everybody crazy, and you don't know this until you design it, which was pushing the blue button.
Mm-hmm.
There was a latency behind some sort of feedback, whether an audible feedback actually.
Right,
There was visual feedback in the LED of the blue button,
yeah,
but you're not staring at that blue button.
yeah.
So
It's
Eugene,
not on, yeah, it's not on the display. You need
Yeah.
to have some way of knowing, did it work?
yeah, so Eugene came to me, he's like, "Die, nobody knows that they pressed the blue button." And I go, and it's awesome feedback in the sense that now that it's out and you see kind of that time delay, like what are the reaction times? How do people respond to different cues? And not just audible cues, but visual cues of directional intent.
Yeah.
So we leverage legacy design from the automotive industry,
Mhm.
where if I am coming up towards you, if I see your blinker going in one direction,
Yeah.
I know that that's the direction you're intending on going. And also the mechanical behaviors.
Yeah, I mean, from a software engineering perspective, we are so used to a screen and a keyboard, and that's typically how our products are run. But, when you're working in robotics, you're working with a large machine that is in a physical environment, and I think what's often overlooked is what a human observer of that robot is thinking as the robot is moving through an environment. So this mechanical cue that you were mentioning, I mean, when a robot, for example, we had one situation where, and I worked on this with my colleagues, Dr. Tiger Lin and Mark Ma,
They're
on the
awesome.
motion planning. They're great. We worked on this feature for U-turns, for making smoother U-turns. When a machine was trained to make a U-turn beforehand, it would automatically stop and go through this thinking phase where it wasn't doing anything. And as an outside observer, when you look at this robot, you want to come to its aid. You're not sure whether or not it's working or not. And making the robot smoothly do these transitions really helped in the outside visual aspect of someone can look at it and they know that the robot is still thinking, that it's still continuing to function. So one of my favorite features that we worked on for sure.
Tying into that motor control, now that we're looking back on the project and everything we worked on, I think one of my favorite unsung hero user experience interactions that our engineers came up with, and it was accidental but intentional at the same time,
Mm-hmm.
which is when the machine or robot comes to an intersection or a path decision-making point,
Mm-hmm.
and it has to decide which way am I gonna go to avoid this obstacle. They left in the feature where the wheel
Right.
twitches and the steering wheel moves a bit. And I remember being out in the field and a gentleman was shopping. The machine beeps, "Hey, you're in my way," showing you which way I wanna go.
Mm-hmm.
And it's planning its path around the user, and the wheels are kind of twitching a little bit, and not in almost if you were to animate what decision making looks like when you look left, you look right.
Right.
That's what the machine wheels and steering wheel were doing. And I remember the gentleman kind of stepped aside, looked around, and he goes, "Oh, excuse me, stepped back, and then the machine drove around in front of him. So we have a few minutes left, and I wanted to kind of look back and think about what are some of your favorite UX moments in the engineering side? Or what were some of the things that you enjoyed working on, or problems that you solved that were really key or not highlighted that people would know about?
Yeah, I think that it's a great point as to a lot of times we develop features and the whole point of that feature is to be invisible.
Mm-hmm.
One of the things that I worked on was false positives. When we use infrared sensors and sometimes we have reflections that show up as obstacles that are not actually there. Now to the naked eye, these things are invisible, but to the robot they are. And one of the filters that I worked on, for example, would be able to detect these false positives and clear them effectively. And what this ended up doing was when we deployed it onto the field, we got far fewer assists or requests for assistances by the robot because from the outside perspective, it didn't look like the robot was stopping for no reason. If before this filter came in, sometimes the robot would just stand in place and there would be nothing in its way, and it would try to move its way past this phantom obstacle, and it would just look awkward. And I think that that particular feature I'm quite pleased with, and its deployment and its aspect with regards to the user experience, a third-party observer looking at what the robot is actually doing.
That's when I got to see that in action and see the perception, not just from our customer side, but from the people that work in our company. Not everyone always gets to see every feature get deployed,
Right.
but there were behavioral differences on how people interact with our machine in the warehouse. And I remember one of the technicians, a customer was in our warehouse and he told him, he's like, oh, hold on 1 second. And the customer, the person visiting immediately said, oh yeah, it's about to turn this way, I'll just go this way.
Wow.
Yeah, that was a cool moment.
Yeah, that's when you know you succeeded in communicating physically, right? Without the robot saying anything, you just look at it and you know what's going to happen. And I think that being able to predict what an autonomous machine is going to do really puts people at ease. And it leads back to our discussion on adoption and trust, and how much people can really put their faith into a machine. And at first they're apprehensive, but as time goes on, and they can tell, they can predict how this machine is going to behave, I think that really plays into the adoption aspect.
Let me think, my favorite, I have so many, but my favorite feature, to close this out before we jump into Q&A, I don't wanna say it's a feature because it's so much more than that. A route was completing, and at the end of a route, our machine messages the janitor and shows a map that says, okay, route's done, this is everything I did,
Right.
obstacles, whatnot. And the janitor that day was preparing for vacation.
Okay.
He was onboarding someone new.
Okay.
And it was a discussion that transpired between two people. I was kind of there as an invisible observer. But as he was onboarding someone new, he said, okay, when you receive this message, come back to the machine. Make sure there's no water around. And then they referenced the map. He goes, if you see this color, it means that area wasn't cleaned. Go back, inspect that area, and then tackle that area to clean it.
Right.
And then
A feature they wouldn't have had before.
they did that, and it was, to me, that discussion when I was talking to the business owner later, I go, this is kind of the coolest part now. There's a way for you, from the business side, to know what was done, what wasn't done, and why. And then from the janitor's point, not only do they not have to sit on the machine and just clean the floor, they can have this tool that cleans the floor, and they can assess if that tool did a good job and be able to just kind of inspect now and see what was done.
Yeah, that's great.
Okay, so at the beginning of this webinar slash podcast, we extended this to YouTube, Twitter, Instagram, and Facebook and said, ask us a question via the hashtag Brains for Robots with the number 4, or through here, and we wanted to open it up to Q&A. So if you guys have a question, oh, and to bring it up again, we will be giving away 3 slide bags. I know I tweeted 2, but our team decided to overachieve and give away 3 instead.
All right. Our first question we have from Kajal, who asks, do you feel like engineering priorities can get in the way of good UX? And if so, how do you remedy that? I think that is a great question for both of us.
Yeah.
From my perspective, engineering priorities can definitely get in the way of UX. In my opinion, and I know it's not very popular with most other developers, but just having been in the industry for a long time, I think that UX should take the highest priority of any product. In my opinion, it is vital to the success of a business, and engineering should take a second sort of seat to that, and we should figure out ways to manage that, and of course within time and cost constraints, and which is what usually happens. But you know, and I didn't always feel that way. I just sort of always felt like, you know, I've created this great thing. Why won't you guys just go and sell it? And I think that realizing that products are made for people to use, and as a result, UX is what bridges technology to people. It really cleared it for me that a tremendous amount of investment has to go into the UX. So I think that how do we remedy engineering priorities getting in the way of UX? Just through education, like we're doing today with this webinar.
And to answer that question too, it's on the UX side that you always have to factor in technical feasibility, and that ties with that engineering timeline. In the same way that engineers are expected to kind of understand and respect that UX is very, very important, it's also, I think, on UX's job to understand technical feasibility. I mean, any technology you're building is going to have its limitations at that moment, and to have an open dialogue about it, and what are the things that can remedy this kind of collision point that we're meeting at. So for example, we're under a deadline. One of the things I love working about with, and I know it's gonna sound cheesy, everyone on YouTube Live is like rolling their eyes going, of course the UX and engineering team there get along so well. But one of the things I love about working here is we have, even in points of conflict, we lay out the parameters. It's like, okay, this is what ideal UX based on this testing data and these conversations are. What are our technical limitations right now? And then being able to jump in that dialogue and work with you guys and say, okay, what if we did this instead?
Right.
What if we developed it this way, and what if it's this architecture? Great question, Kajal, thank you. So I have a question from China.
All right.
On Twitter. Paul Shi, thank you so much for tweeting us. And their question is about adoption. I'm from mainland China, and jobs, for example, janitorial ones, are occupied by people who cannot handle modern day UX, let alone tech behind the scene. How do we accelerate the adoption? I love this question because currently we're working with different countries, we're working in Japan, and how UX works here is entirely different than other countries.
The cultural differences.
Yeah, for example, in Japan, the janitorial industry is kind of your entryway for a lot of people to retire. And it's a way to keep them active and social, so the perceptions are different, the usability is different. But the adoption, how I look at in adoption in this part for UX would be first to look at what you're trying to solve. And in that, trying to maintain the behavior and workflow as similarly as possible to what the janitor's currently doing. I think the biggest UX hurdle we ran into was working with the company and working with the janitor on integrating our technology with their workflow and minimal impact on their workflow. So for example, a big feature of our robot is mapping. So you map a space and you say, okay, this is the area next time that I want you to clean autonomously. How we chose to go about that was having the janitor drive the machine the same way that they would had they been cleaning the floors. So the heavy lifting was on our side, engineering, to be able to get that data, compile a map, make this area, and optimize that route. But on the janitor's end, they had to learn a few UI items, buttons that they had to press, and a couple workflow things like checking the sensors, cleaning the sensors, and adding that maintenance as part of their workflow. So I would love to dive in with this further, but I would say the two best things are, looking at what their workflow is and trying to integrate with their workflow. And don't worry for time, I know we're supposed to end at 12, but we'll stay on a few minutes after if you guys still have questions. I mean, this is our favorite part, where
Yeah.
we get to dive in.
Yeah, so the next question I have here is from William. Kind of ties into what you were saying earlier about UX, and he asks, how do you define a good UX, and when do you know if you're done? My initial reaction is, you never really know when you're done. You can always improve and make it better. But what criteria would you say do you have to have in order to know that you have a good user experience going?
And let's just not say, because perfect UX doesn't exist. As social norms change, as cultural impacts change, as language changes, as technology and other things that we change, those things change. The way UX and technology work hand in hand change with it. For me, when I look at UX and I see that it's sufficient, not good, sufficient at that point, and good enough in the sense is when it solves a problem that we didn't know, that either we didn't know was a problem before, or now we recognize, yes, that was a huge problem and it is now less of a problem.
Yeah.
And I think it's based on the efficacy of the problem you're trying to solve.
Right.
For me, that's UX. It's not just in the interface, it's not just in, can you do this thing now? It's looking at the product as a whole. What is it supposed to do?
Yeah.
Our product is supposed to clean floors.
Right.
Then doing a risk assessment. Okay, well, what is the impact on the environment? I'm not talking like tree environment, but in the operating environment. Okay, so are the customers impacted? Is the business impacted in the sense of what they're trying to do and solve their problem? Is the janitor impacted in doing his job? And it's a multitude of form factors, and we never hit all the targets, but that's what you aim for, in the sense that you aim to not impact other things in a negative way, and you look to solve the problem that your product was supposed to solve. So for us, cleaning floors, or using another application that isn't tied to our robot, as simple as like a mailbox. Can I send out mail? Can I have mail go out? Is this at an optimal location?
Right.
Does it interfere with traffic? Is it discoverable? What would be bad UX tied to that? I can't put anything in this box that's bigger than 2 inches in
Right.
width. Things like that.
Right.
Or the handle gets too hot in the sun and I can't touch it to
Right.
open the mailbox. And I think that's the thing that I strive for with engineering and looking at the product and talking to the product team, is that I don't think UX is the role of the designer. I think the designer facilitates that conversation, and it's a holistic, impactful thing on everything else that touches it. That's a great question. I love that question.
And I like your point to the dynamic nature of UX and how it evolves with people, alongside people. Very interesting.
I'm pulling up another question right now.
Okay.
How do I see, oh, here, let's grab some of the webinar questions. Coming from Chad, is UX inevitable towards real AI or moving independent to fill the need of making current robots smarter? Both. I think depending on the company you are and what you're trying to build, okay, well, first let's address the definition of real UI. I think there's the media perception, and there are the things that we see in movie, where AI sometimes get tied to humanoid.
Yeah, I think what he's referencing might be what's AGI, right? General artificial intelligence. So just to make that distinction, because we already have AI filling quite a few roles. From speech recognition to optical character recognition, facial recognition, quite a bit of AI is actually employed. But I think what he's referencing there, yes, indeed, is general intelligence. And so the question is it inevitable towards real AI, or is it moving independent to fill the need of making current robots smarter?
And I think it's both. And it's depending on which current robots we're discussing.
Mhm.
If it's towards our current robots, and I wanna expand this conversation beyond just our products. I think the reason why I say both is, on one hand, you have this necessity of AI needing to be smarter
Mhm.
and to be more efficient at understanding what we need.
Right.
So there's that machine learning aspect. And then there's the other aspect of, okay, we have existing technology, say like a self-driving
Yeah.
car, and things that are automated, that also needs addressing. And
Yeah.
I think they're not mutually exclusive.
Mm-hmm. Yeah, and here he is, he did clarify, he meant Aggie AGI.
Okay,
So our next question,
let's talk to, are certain modalities better? Voice, haptic, etc.
by Tony.
By Tony. Thank you, Tony. I love this question because when we talk about user experience, it ties into all of our senses.
Mm-hmm.
And the reason why I love this question is because then we get to talk about accessibility. When designing a product for robotics and AI, in the beginning you assume that your intended audience has all senses.
Right.
They have vision, they have hearing, they have feeling, they have, let's ignore sense of smell for now. Let's ignore taste. I highly don't recommend anybody taste our robot, or any robot for that matter, or try to sniff it. But some of the cues, depending on the function, and Tony, please don't get mad at me for this, but the question really does depend on the function that you are going towards. So let's talk about voice and haptic and
feedback.
and haptic
visual,
feedback
yeah.
and visual. For example, in an environment where you are surrounded by a lot of people, audio may not play that great of a cue.
Yeah.
In that case, you may need a strong visual cue. And I'm not talking about beaming strobe lights
Sure.
from the machine, but factoring in, say, reflection. Right now, there are certain robots that we've been assessing that operate in office environments. In an office environment, haptic feedback isn't an option. Audio feedback can be very, very disrupting. And LED or visual feedback can be also disrupting. So what do? Well, you have minimal LED or visual cues, but potentially you can bank on, what if there are environment items that you could reflect off of?
Mm-hmm.
So for example, office windows.
Mm-hmm.
If me walking down an aisle can get visual cues from an LED or some sort of visual cue, then it helps me to interface with that robot.
Yeah.
What do you think?
No, I agree. I think that it really is dependent upon the role of the robot and where it's being deployed. I think, if you're riding the robot yourself, like you do in a Tesla autopilot environment, for example, the haptic feedback definitely needs to be factored in. If the machine is suddenly going to be making turns and making you feel uncomfortable and dizzy, that's not a good experience. But to our point earlier about a robot, for example, that is large enough to be visible, not necessarily through LEDs or through lights, but just through behavior and how it moves in the environment. If it's natural enough, I think, would really improve the idea of being able to accept, and for people to be able to accept operating in the same space as a potentially dangerous robot.
Okay, do you want to tackle another question from the webinar, and I'll look at
Well, let's
these
see.
Facebook?
What do we have?
There's a few really good ones on Twitter. I'm excited about this.
Yeah. So let's see, there we go. There's Tony, our certain modalities.
Let's tackle this one. Andrew Bennett, thank you for submitting a question. Do any of your systems have a UX that easily switches into another language? Many businesses in the US have a cleaning staff that primarily speaks English. In parts of Canada, devices might be required to have a quick switch between English and French. especially if used to clean government buildings?
That's a great question for you, Di.
That is a great question.
Yeah.
This is something that we're still working through, which is the localization aspect, and it's never easy. Let's talk in reference specific to our machine first. Yes, the dominant demographic when it comes to the cleaning industry is very, very multicultural.
Mm-hmm.
And even when we're looking to expanding into different cultures, there's a trade-off between being able to switch language easily and then designing for this concept of a non-language
Cute.
kind of
Yeah.
communication
Mm-hmm.
intent. So when we were designing our machine, and when I look at designing the machine, I try to use terms that are terms and iconography that are as global spread as possible. So for example, the play and pause mechanism
Right.
with our robot,
Yeah.
using play and pause, using colors that tie to error, for example, like red for anything that's tied to emergency or an error. Emergency lights when our machine goes into an assist. And I know you were talking about language, but I'm trying to tie into kind of the UX things that we did to transcend just the spoken language. Using the blinking lights, for example, as an emergency stop
Yeah.
behavior. And then using single words that could be translated. The other side of it now is the supporting technology that we have behind our robot, and this is something that we call our rock.
Mm-hmm.
And software-wise and cloud-driven wise, we have this communication that comes down that knows where the robots get deployed.
Yeah,
and
our
without
fleet
it-
management,
Our
absolutely.
fleet
Yeah.
management, where now depending on what machine goes to which country, we can then set the language to that country.
Yeah, and so from a technical perspective, this is something that, we just use UTF-8 strings, and we can just, send the strings out for translation. We don't really think about it from an engineering perspective. But I think that, having worked with UX, the less people can read, or the less people have to read, the better the experience. The more pictures that we use that are, as you said, internationally recognizable, the better off we are. So while the software certainly has that capability, I think the decisions surrounding what should be a written sort of statement or a written instruction versus iconography or using internationally recognizable characters is the way to go, I think.
And I think to start out with, if you are doing design and you're thinking about the localization factor, just having awareness into that and knowing that it's an ongoing dialogue is one of the biggest important things. Like right now, we're still working through how we manage that ease of localization and conversation and error messaging to new countries. And it's going to be an ongoing thing because until you are adopted within that culture and that country and that language space, there are fine things in our conversation that you would not know unless you were in there.
Yeah.
So those are things that are constantly evolving. Okay, let's grab another question. Should we... do you want to tackle this one or should we give someone else a chance?
No, I think we talked about it, AGI, real AGI would replace.
Oh, actually, this is a good one. I want to tackle this one.
Okay.
Recommended readings on the subject. Ernesto, absolutely. Rather than listing everything here, what we'll do is tied to the webinar and to the YouTube live video that we'll have on YouTube, on our YouTube channel. In the description box, Hamid and I will put in recommended reading. And not just for UX and design stuff, but our favorite books on AI, on robotics, getting started, all of that good stuff too.
Two that come to mind for me, for regarding AI, The Mind's Eye, it's an older book, yeah, and regarding UX, what really changed things for me was the design of everyday things. I think
That's a book
very,
I think that book in itself is UX designers like write into Passage.
Is it?
Yeah, that and like the lean startup, of course, but we'll definitely, there's a lot, so I'll put in my favorite websites, my favorite blogs, we'll put in some recommended reading, and we'll add it to this webinar and also the YouTube live description box. Let me see if I can
Alright.
grab another one on Twitter. Oh, and for everyone joining, we will pick a random winner of everyone that asked a question and reach out to you guys to send out the swag bags. Twitter is good, I'm checking Instagram for questions.
Okay. Are we doing on time?
We're at 12:09, we
Okay.
started at about 11:05, so we're doing good for time.
Okay.
And then if you wanna scroll through and see if there's anything else while I'm searching different hashtags.
Let's see. Another question regarding the phantom object that confused the floor cleaner. Actually, light refracting through clear bottles of liquid on the bottom shelf. It can be, we have lots of different scenarios where infrared sensors will bounce back. There's lots of mechanisms and algorithms for clearing those false positives, and we actually assign a confidence score to that. So it could be anything. It could be steel appliances at the end of a hallway.
It could be a huge, another infrared source meeting our,
Like heaters, for example,
Yeah.
overhead heaters we've had problems with. There's definitely various sources that can create those phantom objects.
direct sunlight,
Mhm.
like direct intense sunlight,
Yeah.
a
That was-
dirty sensor. I actually, tying into this conversation, this UX portion was really cool, speaking either to you or someone on our team, but detecting kind of if the sensor is dirty or not. That was
Mhm.
actually a question that I got from another customer side was, how do we detect that if the sensor's dirty?
Yeah.
So for example, on our LiDAR, you have a laser that constantly scans.
Yeah, and it's pretty close to the floor, and the floors are dirty, and,
Yes,
and we're
exactly.
cleaning them, so yeah.
But in that scan, there's a constant, if you were to describe it in the movie sense, there's frames that are
Mhm.
moving through. And then if you had one static pixel that didn't move with the rest of the frame moving through,
Yeah.
that's how we detect that the
That
sensors
the
are
sensor's
dirty.
dirty, yeah, if it's very close to the sensor and we're getting that reading everywhere we turn, then that's how we determine that it's a dirty LiDAR, so.
Yay, okay, so that is all the time that we have for today. This was awesome, it was a lot of fun.
Yeah, thank you for
And then
having
hi.
us, yeah.
Thank you to everybody on
Thanks for
YouTube that
joining.
stayed on. And don't forget, our next webinar is going to be on how the voice of the customer should drive product definition and development, Wednesday, October 17th. And if you guys have any more questions that we didn't get to answer, feel free to tweet Brain Corporation, use the hashtags, reach out to either Hamid or myself.
All right, thank you again, everyone.
Thank you, Optimus Prime says thank you. Bye guys.
Oh.